Yes, lecture about, over 20 years, 10 years? Because I remember
17 maybe?
17, so 17 years of experience in the industry. They're working on a startup right now. It's a blockchain Bitcoin startup. I would have to leave it to him to actually talk to you a little bit more and start thinking about some extra questions you might want to have at the end of the class beyond the scope, right? Beyond what we're teaching every day in the class, beyond what he's talking about. He's going to show us the technology, the different coding languages, and also text-driven development in here today. So start thinking about the questions now. So cool.
Thanks, sir. All right. All right. Thank you for having me here today. I made a PowerPoint, so it's very exciting. So I'm here to talk about programming languages, unit testing, and other fun stuff. It's kind of a two-part thing with a one-part, hey, if we have time, here's some points. My name is Matt David. That's the date. About me. In the past, I've worked at 2 ISPs and a large web content provider. Right now, I'm at NetKey, where we do cool stuff with Bitcoin, cryptography, all that kind of exciting stuff. And in the future, I'll be a space nerd, or not. So what are you interested in? Is anybody interested in anything in particular? Are you here because it's just an exciting warm room?
So for me, the nice thing about the ITP classes is I think a lot of people in them are doing it as a minor, so it's not like computer science necessarily. So for me, I happen to really like the environment in China, and I've done some stuff with web designing for various NGOs. But then this was a cool way to get team experience with web app development.
Very awesome. Well, team experience is very exciting. It's very rare these days that you can work by yourself. So the first thing is programming languages. There are so many programming languages, so much code to write. I've written code in every one of these languages. The latest ones I've used are JavaScript, C#, Go, and Ruby, and I've used them to write client libraries basically for our company's products to access the API. What I've learned is that basically after you learn something like a C++ or a Java or kind of a base programming language, everything else becomes kind of straightforward. You understand the concept, and you can write it in almost any language once you figure out the syntax. New languages abound. So here we have Rust, Scala, Clojure, Erlang, Groovy, OCaml, and so many more. They're coming out all the time. Who's heard of any of these languages? Sweet. Have you written in any code in any of them? No. Okay. Yeah, Rust comes to mind as one of the newest. It's at version not 1 yet. It's a language that's still in beta. So there are lots of new and exciting features. Unfortunately, they're not all 100% there yet. In the real world, you have business requirements for a language, right? You need your languages to be full-featured. You need them to have a wide range of available libraries. Things like looking at JSON data, right? If you're using an API. It's really easy to do that in something like JavaScript or Python or Ruby. But in something like Go or C#, it becomes kind of painful. Another example is Go has very few libraries available, period. The system works, it's good, but it's so new that there are very few additional libraries out there. People writing code for them and posting it on GitHub or some sort of module site. And you need a supportive and growing community. You need to be able to go on Stack Overflow or something like that and say, hey, what's going on? Or be able to look up a question on Stack Overflow and have an answer to it, especially if you're just getting into the language. Otherwise, it's going to be a very large barrier to entry. And unfortunately, even languages that are mature like JavaScript, there's no such thing as a DNSSEC library, which is something that we're using, which is secure DNS. So not everything is available in all languages, even very mature languages. Language is the tool, you are the craftsman. What does that mean? Nothing? I've been there, I get it, okay. So the idea is, the important part of this is truly understanding how to solve the problem. It's not the language, it's you, okay? For example, concurrency. If you're trying to make one web request, you can use Python. You need to make a web request to an API, you can use Python. It has this thing called the global interpreter lock, which really means it's single-threaded. It doesn't really have multiple threads. You can use threading, but it's not really threading. What if you need to do 10,000 requests a second? Right, you're not going to use Python. Maybe Java or Scala or Go. If you need to do 10 million requests per second, Google kind of wrote Go to do that using Go routines. You define a function and you say Go, routine name, and it just goes off into concurrency. For example, I wrote a web crawler that had to crawl 4 million pages every hour at one of my jobs and do tests across all 4 million pages to make sure everything was okay. The crawler was written in Java. All the data processing and testing was done in Python. Java's super fast for concurrency. Python is very easy to write tests, sort data, filter through data, all that kind of stuff. So really what you have here is that understanding concepts is the important part. It's not really the language, like I was saying earlier. There's no best language for the job, and most of the time at least. But you need to understand the concept and the problem when you're choosing a language, because there are better languages for solving problems. And understanding the problem you're trying to solve and using online resources to help and implement the solution is a good use of tools that are available today, things like Stack Overflow, etc. But if you're just copying and pasting code without really understanding the problem, you may not be actually solving the problem. You may be actually introducing defects. Sweet. All right. So choosing a programming language. This is a long slide. If you want to ask questions during this, please do. There's a lot of there's a couple bullet points, but there's a lot of explanation here. Static versus dynamic typing, right? Generally, with a statically typed language, you're defining every single type that you use, right? When you compile it, you get errors saying, hey, this is the wrong type for this thing, right? Something like a C++, a Java, a C#, any of those kind of things. Generally, a statically typed language has more code. It is a little safer. It's actually a lot safer depending on the level of experience of the software engineer. Dynamically typed languages, you can kind of just make stuff up. There's no typed variables. You can do testing much more easily. You can say, oh, well, this web client that I have here now is this thing that just returns canned responses for my testing, right? In static typed languages, you have casting, you have reflection so that you can look inside. And something like Python, you can just look at the object and you see exactly what's there. It's much faster to write in something like that. There are trade-offs, of course. And we chose Python at NetKey because we needed to get stuff done really fast. While it's been around for a while, it's a very modern language. It's really well supported. If you need to know how to do something, chances are it's already been done, and you can just look it up. So next we have concurrency. So it's kind of linked with performance, but the performance that I'm going to talk about is a little different. So with concurrency, good concurrency, you have things like Java, Scala, things that run in the Java virtual machine, right? The Java virtual machine was basically made by Sun to run on their hardware, which was highly supportive of concurrent programming. And it runs like no other. It's really, really fast. Things like Go that are built for concurrency in the base language, and JavaScript if you run it with the right engine, which in this case would be V8. So that's both on the browser side and if you're writing something in like Node.js. And you have OK concurrency, things like C, C++, C#, things that weren't really written with concurrency in mind, but have kind of grown over the years, and they have libraries. C# has concurrency in mind, but it's still a little sticky. And not great at all. Python, not great for concurrency. Ruby, PHP, not great for concurrency. But bad local concurrency can be overcome with things like Celery or Beanstalk or other job queuing systems where the OS handles the process concurrency. So it just runs processes of their jobs. Performance, the basic thing I have here is that your performance is between compiled and interpreted languages. Compiled languages, C, C++, Java, whether it's bytecode or bitcode, you're going to get a faster execution generally because you also have the compiler that's optimized, right? It can say, oh, I can skip all this junk, I don't need it, and you essentially get some faster execution time. At this point in time, it kind of becomes negligible unless you're doing a very high performant application. Just because, bless you. Just because we have so much computing power. I mean, we're not running on a 486 or a Pentium or something like that, like way back. Next, we have memory usage. So different programming languages handle memory differently. Some have garbage collection, things like Java, things like C#, that kind of stuff. They just handle memory for you. You don't have to deal with anything. It's exciting. You can be lazy, unfortunately. Then there are other languages like C, C++, even Go, where you have to allocate your own memory and free up your own memory. So what this leads to is generally garbage collected programming languages are usually a bit bigger in memory because you have to maintain a list of all of the variables. You have to say, oh, well, this one wasn't being used. I can delete it, all that kind of stuff. And there's garbage collection options that you can set, right? Say, do it now, do it faster, do it slower, do it when we hit this limit, and whatever. So that relates to object size. Generally, you're going to have a smaller program if you're like running something in C or C++. And then we have useful constructs. So things like generics, which I'm not sure if you know what that is, but they're available in programming languages like Java after 1.5. C++ has them, and C# has them. Write one thing for a bunch of different types of objects. Things like the Go routine in Go that I keep coming back to for some reason. Also, things in Python and Ruby that are used in data science a lot, just because they're so easy to search, filter, sort, etc., large sets of data in one line. You have these things called list comprehensions in Java, where you can do one line, sort whatever you want, filter whatever you want, run operations against whatever you want in a line. Really, really simple on giant lists and sets and stuff like that. JavaScript also has promises, although that's not in the JavaScript that's in the JavaScript that's coming out, which makes callbacks just look pretty. The code is just much nicer. I don't know if you've ever been stuck in JavaScript hell, where you have a callback to a callback to a callback to a callback, and you hate your life. Then we move on to requirements. So, of course, if you're writing a web application, you're going to use JavaScript. You're in a browser, that's kind of where you're at. You could use CoffeeScript, but it compiles down to JavaScript, so it's kind of the same thing in the end. You may have existing systems or databases that you need to connect to that there's no driver that exists for anything outside of one language. And then there's things like, you're working in Windows. You need to do some Active Directory stuff because that's what you're doing, and you need to use C#. And that's kind of there, or F# or any of the Microsoft kind of languages. Visual Basic, if you dare. And the market. So let's just say you've created a startup. You're the CEO, CTO, marketing guy, janitor. You do everything, right? It's all you. So now you just got a seed round. Okay, now you can hire some developers. What are you going to do? Are you going to write it in a language that has 5 developers out there that are really passionate about it, but there's 5 of them? You know, how long is it going to take you to hire a developer? How long is it going to take you to, or how much are you going to have to pay them? Because there's 5 of them, right? You'll see later Facebook ran into this issue with PHP and C++. If it was 1991, you'd be fine. You'd find tons of C++ programmers. It's not. They need PHP programmers. And that's kind of really, the 2 bottom ones are kind of the business requirements. So it's things to think about, even if you're not writing the code yourself. You know, you need to make that decision early on so that you can have something that is supportable and maintainable, because your code doesn't die when you're done with it. Your code dies a horrible, long, gruesome death over a long tail of time until people stop using it, which is very happy, I know. So, examples. First, Facebook. So Facebook was written in PHP originally. In fact, it's still written in PHP, but let me continue here. They tried to move it over to C++. That was very difficult. There are not very many C++ programmers around. And if they are, they're expensive. So what they did is they actually created this thing called Hip Hop VM, virtual machine. It's a just-in-time compiler for PHP and Hack. Right? So basically, what it does is well, here, I'm going to read you a quote from a senior Facebook engineer. So number 1, these are his 2 points. Hip Hop programmatically transforms your PHP source code into highly optimized C++, and then uses G++ to compile it. Hip Hop executes the source code in a semantically equivalent manner and sacrifices some rarely used features such as eval in exchange for improved performance. Sound cool? Yeah, that's what I was thinking too. And his second point is, one common way to address these inefficiencies is to rewrite the more complex parts of your PHP application directly in C++ as PHP extensions. This largely transforms PHP into a glue language between your front-end HTML and your application logic in C++. From a technical perspective, it works very well, but drastically reduces the number of engineers who are able to work on your entire application. So that's what I was talking about with the market before. In fact, I haven't written C++ except for some Bitcoin or Namecoin stuff recently, but it's been years, literally since college. And Twitter, very exciting. Who's seen the fail whale? You've seen the Twitter fail whale? Okay, so for those that aren't active Twitter users or are not as old as me, Twitter used to have this thing where you'd go to Twitter and you'd see this giant fail whale. It was a whale being held up by little birds, right? And what that meant was, no. It just meant, no, this server's not working, whatever, we're done, right? So that original code was written in Ruby. Okay, it was a giant monolithic piece of software. It did like one thing, and then this thing, and this thing, and this thing, and then finally got back to you. It was just not working. I went to a talk with the SVP of platform at Twitter a couple years back. He basically said Ruby sucked for this. So what they did is they went about deciding what are they going to write their code in, right? So they ended up deciding on a JVM-based language because the Java virtual machine handles concurrency really, really fast. And they ended up on Scala because Java's a little more verbose. Scala, you can get a lot more done in a lot less lines of code, right? And in that vein, they build a platform called Finagle, which is a fault-tolerant, protocol-agnostic RPC system. So basically, there's nodes everywhere, a bunch of workers. This one's down, it goes to this one. Everything gets routed everywhere. This says, register services for availability. It was really cool. It was really cool when I saw it. I was actually trying to use it at one of the companies before, but they weren't having it. So it happens. So does anybody have questions about programming languages and why you would choose one or the other? Is anybody interested in anything that I've mentioned here about what I've done that I can answer questions about? Sweet.
Any given points that you have to be forced to switch your language in the past?
Yeah, actually when I started working at the large web content provider, I'd been doing Java for a number of years. And I was ready to leave there. I went to this new thing. I said, okay, so what do I have to do? They're like C#. I'm not really a Microsoft guy. I don't really do a lot of that kind of stuff. So I learned C#. It took me about 3 weeks, and I had to do C#.
Like, how does that 3 weeks get you to, like, from a very experienced Java programmer to a C# guy? Like, what level would that be? Or is that equivalent level, or?
It was in 2011. I think I'd probably be at an intermediate level. Like I was saying before, the key here is knowing what you need to do. So if you need a hash map or a dictionary, or you need some concurrency constructs, or anything like that, you know what you're looking for. You can go on Stack Overflow and just look it up. Someone's done it. You know, you can look at MSDN in this case.
Yeah.
Someone's done it, right? They all have the documentation, and because you know what you're looking for, you can find it really easily. And that's really the big thing that I'm trying to hit home here. I think a really good software engineer is able to switch languages because really to them, the language doesn't matter. It's the problem that you're solving and how you're going about solving it, right?
Which tools you use, back to the tools and the Graphics problem, right? So,
Say that one more time?
which tools would you use as a tools, right? So, back to that early slides, Craftman and tools problem.
Exactly. I mean, the best software engineers that I've ever met, they can do whatever needs to be done. They're really just true engineers. They like solving problems. They don't care what language it is. I had to learn Ruby recently, and until about, I don't know, 2 months ago, I really had a visceral dislike for Ruby, just because I really don't like the syntax. You know, it's just not a thing that I like. But, you know, I needed to do it, so I did it, right? I needed to do it because we have, you know, customers that use Ruby. And if we want them to integrate with us, they can use our library that we've written, and it'll take them, you know, 2 hours. Or they could rewrite every single API call from scratch, figure out how everything works, and at that point, they're going to be like, no, I'm not going to do it. Because, you know, it doesn't matter if my boss is telling me this, I'll just wait on this, and it'll get implemented in, you know, 2 to 3 months or something when I figure it out, when I have some time, right? So even if you need to learn a new language to write something small, just to get an integration done, if you're doing like a business-to-business kind of thing, it's totally worth it. It's quick. I think I wrote that client in about 4 days. With unit testing, I did Go for that same very reason. I learned Go. Go's a little longer because the unit testing was a bit strange because I hadn't written unit tests in a statically typed language in a long time. So I wrote it, unfortunately, this way I should have written the test first, but I wrote it and then I went back to testing and I had to make a few changes because I had totally forgotten about it. And that was my biggest issue. That was actually my biggest learning experience from that.
And we were about to step into the test-driven development, so that actually starts, well, throughout the questions for the testing-driven developments. So.
Perfect. So,
any other questions here for using different languages? Any complaints on the language you're using right now? All right.
you guys are all using PHP?
Some of the groups are working with WordPress, so PHP is a must.
Nice.
And what about the
We're just JavaScript.
JavaScript?
Nice.
Okay. Cool.
So now testing for fun and profit, or how to reduce the risk of a profit-affecting bug. So I have this really awesome slide here because it's a chart. So what you're seeing here is you're seeing relative cost to fix defects. This is in time cost, right? So in design, it's a one-time multiplier. Okay, you wrote the design, you say, okay, that's bad, you rewrite the design. It takes about the same amount of time generally, right? This is all data from IBM. In development, it's a 6.5 times multiplier, right? You need to go back, look at the design, redo the design, redo your dev, really check it now because now you know that there's a problem with it. In QA, it's 15 time multiplier, right? So not only do you have to go back through design and dev, but you have to run through the whole QA cycle, and your change may be a small piece of a larger change, right? So the whole QA cycle has to be done. And then you have a production bug. So this is a 100 times multiplier in time cost. I've seen just cost multipliers in the thousands, for real.
Yeah.
Horrible, horrible, horrible bugs that I will talk to you about without naming names. So time cost, basically, like I was saying, design is your time to rewrite the requirements and the design. Dev are your dev hours. right? If you find a bug in QA, you have those dev hours, you add in a systems engineer, you add a product manager, and QA hours, right? In production, not only do you have the support hours and the customer hours and this customer frustration, but you have the potential loss of a customer, you have a potential loss of revenue, and you have a potential loss of reputation, right? These days, something goes wrong, someone goes on Twitter and says, oh, your stuff's not working. Then everyone gets to see it, right? And they're just like, yeah, I'm not doing that, right? So not only are you losing that customer, but you're probably losing potential customers, right? And if you want to make money writing software or having a tech product, that's a really bad idea. My friend actually sent me some information about the introduction of defects, where defects are introduced in the process. And by the way, by process, I mean SDLC, which is a software development lifecycle. I don't know where you guys are in your program, so it's been a while since I've been in school. So 20% of defects are introduced in the requirements phase. 25% in design, 35% in coding, which I think should probably be a little higher. Documentation, 12%, which that's shocking. And even more shocking is 8% of defects are introduced in bad fixes. So you broke something and then you broke something again, right? That's awesome. And I've been around doing this for a bit. So I have two really good examples of production affecting bugs that just really screwed the company in a bad way. One was at an ISP where there was back in the dial-up days, there was a file that went out with phone numbers in it, right? And that's how the dialer would choose where you dial up to. It was zeroed out. It was just empty. And it went out. And no one could connect to the internet. This is a very large ISP. CDs, physical CDs had to be sent to users. And they lost millions of users. Millions. Monthly users. Okay? This could have been caught with one unit test. Is the file not empty? Right? Okay. Millions of users lost, and the cost of sending out CDs to millions more users. Just mind blown. All right, so the next example is if you know much about HTTP and you know much about Google and how it does its search rankings, there's a header called an X-Robots header, right? So at this company, the X-Robots header was mistakenly changed to no index, no follow, which means don't put me in Google. This is a company that gets traffic from Google, a lot of traffic from Google. This was a loss of hundreds of thousands of dollars per hour, okay? Millions of dollars in total loss, which is ridiculous. I mean, that's a staggering amount of money. And this is a single header, one header. So once again, one unit test could have saved millions of dollars. I think it's even better when you say hundreds of thousands of dollars an hour, because that's nuts. So now we do testing. This is the exciting part. So we have different types of testing, right? We have unit testing, integration testing, functional testing, and end-to-end testing, right? So unit testing is white box testing. What that means is you have access to the code. You can see everything it does, right? You're going to test each unit of code, hence unit testing. You're going to cover all the code paths, so all conditionals, all branches, all exceptions, all that kind of stuff, right? And you're going to do positive, negative, and balance testing generally, right? Positive testing is, I want to make sure that this thing does what it's supposed to do. Negative testing is, I want to make sure this thing doesn't do what it's not supposed to do. Balance testing is, for example, you have a function that's for a rating system maybe, right? You want to send in a number from 1 to 10. That's your rating. What happens when you put in 11? Does it handle it correctly? You have a thing that takes 100 strings. What happens when you throw 200 at it? What does it do? Right? What is it supposed to do? Right? So that's unit testing in a nutshell. This, by the way, is a very, 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 very high-level summary. I wish it were that easy. Then we have integration testing. Okay. Integration testing is where you have individual software modules that are combined and tested as a group. So Class A depends on Class B, and Class B depends on Class A, or whatever you have it, right? You make sure that they work together correctly, and that's integration testing. All right. And functional testing is black box testing, which is the opposite of white box testing. You don't know what's going inside, and even if you do, you really don't care, right? You just need to make sure that it does what it says it's going to do, right? So you're basically making sure that an input gives you an output, right? Whether it's code, like a string that gets reversed on the out, or whether it's you click a page on a website, or you click a link on a website and like a JavaScript function runs appropriately, right? You make sure it just works, right? And then you have end-to-end testing, which is the fun part, where you test the whole flow of an application from start to finish and make sure it's behaving correctly. For example, you have an e-commerce site. You want to make sure the user can log in, search for an item, add it to a cart, check out, do their billing page, get a confirmation, make sure they receive an email. Not even that an email sent, to make sure they receive the email, right? If you're writing an API, you may want to do, you have a REST API, you might want to do CRUD operations, right? Create, read, update, delete, just to make sure that it works through the whole life cycle. Does anybody have any question on these types of testing?
It may be coming up, but you mentioned with the with one of the things you wrote recently that you had to rewrite it because you weren't planning on testing from the beginning. Are all 4 types of these tests something that you want to like keep in mind while you're writing something originally?
Yeah, so this is coming up, but the key here with testing is, it wasn't that I wasn't planning on testing.
Yes.
But, no apologies. But it was that I had forgotten about writing statically typed languages. It had been, at that point, 4 or 5 years. Right? I've been writing mostly in Python the last few years until very recently. And so basically I had to do some rewrites. It wasn't as bad as I thought, but yeah. And that's coming up. You know, you need to test like all the time. All the time. So up here we have test-driven development. I don't know if any of you have heard of this. It's been around for a little bit. Basically what you do is you define your requirements before creating your tests. Then you create tests before writing code. Then you write the test, you write the code, you test the code, you fix the code, and you repeat. Basically what it is you're writing a test that says, or a series of tests that says, this is what this thing does, and then you write the code. Because what it allows you to do is you actually get better design out of it, because you've fully thought through the whole function, let's say, right, or the whole object. And you end up with better design. You also save time coding, you also save time in defects, because you have fewer and less severe bugs. The fact is if you're writing this stuff, when you're thinking about it, you're going to think about everything, right? You're going to think about everything there because you're in the moment and you're writing that code. You know what you want it to do. And you know, it makes you think about the results of the code that you want. It makes you think about the results that you want your code to produce before you write the code, right? And so if all of these Y's are true, better design, time saved, fewer and less severe bugs, you actually get a quicker time to market. Because your beta doesn't last for 3 months or 4 months, it lasts for like a month. Because you've actually fixed all your bugs, you observe it in the wild, and it's out, right? And time to market these days is huge, right? So here's a unit test example. Oh, sorry.
So like, does QA write the test originally then, or like, are you responsible for writing your own tests and then developing your code? Because that would like change kind of like the cycle of like who's doing.
Yeah. So basically, where I've worked, where we've had like, I mean, we're 6 people right now, right? And we kick ass. But I've known these guys for 15 years, right? But even when I was at larger companies where we had a QA group, the QA group does not write unit tests. You write your own unit tests, and the reason you write your own unit tests specifically, they may write some functional tests or some automated testing. But you write your unit test because you know what code you want to write, you know what it should do, and also you need to test all those exceptions. There are certain things that will happen in QA. There are certain things that will happen that you want to support in your development, in your code, that might never happen in QA. They may not get around to thinking about it because maybe the requirements aren't great, right? If you live in like a perfect world where everything's a utopia and they know exactly what's going on and they're also the best quality people and they never mess up, then yeah, they're gonna run into it. But that's not the real world, right? There are varying levels of skill, there are varying levels of ability to concentrate, speed, that kind of thing, right? So you need to do it. So here's my unit test example. It is quite possibly the simplest function that you've ever seen. So this is written in Python, just because of the def. So this adds two numbers, okay? So it's simple, right? It adds two numbers. What do you need to test? Okay, so let's go through it. I have nicely placed numbers next to all of these lines of code, which are very small on my screen. So our first test asserts that 1 and 1 equals 2, right? That is a positive test. Right? We're making sure that that comes out. We're asserting that 1 and 1 does not equal 1, unless you're a magician. And that is a negative test, right? You're making sure that that doesn't happen. Test 3 is you're making sure that when you add 1 and 1, you get an integer out of that function. All right? Test 4 is you're asserting that when you add the maximum integer and 1, that your result is an integer. Okay? Sorry if this is grueling, but it's very exciting stuff. Number 5, you're making sure that negative numbers work, so it's a positive test, right? You're adding negative 1 and 1 and making sure that you get 0 out of it. 6, you're adding 0 and 0, making sure 0 comes out of it. Right? Those are positive tests. Tests 7 and 8 are type checks. So you're making sure that if you add the number 1 and the string, you get an exception. Okay? Same thing, the next one, number 8, is you're checking that if you add none and 1, none being like null or nil or whatever programming language you want, you get an exception. It's a type exception. Now, there are nicer ways to handle it, but that function would be much longer and wouldn't be a really good example of the simplest possible function. Okay, so now here's the question. Which one of these doesn't pass?
Is it the one where you take the max and add 1?
Yep. So basically you get a long out of it. No more integers. So if you wrote this originally and you maybe your addition you wanted it to carry back, right? If it's maximum integer, then go back around, go to the negative side or go back to 0 or go to 1, right? Maybe you actually mean it to do that, but that code's not going to do that. All right. Does anybody have any questions about this? Does anybody have any questions about what an assert is? Yeah.
How do you know how many tests you really need? Because I mean, in this example, you have 8 for a fairly simple function, but you could theoretically have even more tests on this. So where do you draw the line with having too many tests or too few tests?
Well, if you ask my buddy Frank, who you don't know, and that's why she's laughing, you can never have too many tests because he is paranoid. Okay. The fact is that if you're running through at least a couple positive test cases, a couple negative test cases, bounds checking, type checking, you're covered. And you need to make sure, so if there were an if statement in here, right, if x is greater than sys max int, whatever, then you need to check that branch specifically, you need to check when it is true and when it is false, right? If you're expecting an exception, you need to be able to test those exceptions. You need to make sure your handling is working correctly. So basically anywhere that the execution could go in the code, you need to test that. Did that answer the question?
Yeah.
Okay. So now test frameworks. okay? PHP has PHP unit, Python has unit test, Java has JUnit, C# has NUnit, JavaScript has Karma and Mocha. So has anybody here done unit testing before? Sweet, congrats. Good. Yeah, I have a couple fun statistics here later about our code base, but unit testing is really, really, really important. Really important. So part of these unit test frameworks, or additional to them sometimes, are mocking, stubbing, and spying. So what's a mock? Right, a mock is, it's an object that has expectations set up for calls and verifies that that has happened. You can also set them up to return certain things, etc. A stub is purely an object that just returns the response. It doesn't check anything, okay? And a spy is a proxy wrapper around an existing object to track a call. So let's say your code sleeps for 5 seconds for some reason, right? You're not going to mock sleep. You can put a spy on sleep and say, was it called? Was it called for 5 seconds? Right? You don't need to mock it. You can spy on it. In some language, you have to mock it. But why would you use mocks or stubs? All right, so no external dependencies. All right, when you're unit testing, you're supposed to be testing just that code, right? Let's say, I mean, you know, this is the world of today. You're hitting an API server to do something, right? You don't want to have to use someone else's API server to test and rely on that data to be correct. You don't want to set up your own API server, because then you have to write a whole test API server that does certain things in certain orders. You just want to create an object, your web request object, say, okay, this returns HTTP status 200, and here's this data, or a 301 and this redirect, or a 500 and whatever, right? It's quick. There's no complications. You just say, this is what I want, and you know that you always get it in your test case. And that's how you can test all of your branching and kind of stuff like that, right? Whether it's a database, what a database, like a database access layer returns, what a web request returns, anything external you want to mock, okay, in unit tests. Again here, dependency injection and in static and dynamic language testing. In dynamic language testing, it's a little easier to just say, okay, my old web client is now this fake one that I've just given you. Right, that's easy, that's done. In statically typed languages, generally, you need to provide a way to provide a fake object to do that testing. Right, which is what I ran into with the Go stuff when I was doing the testing. Because I needed like a DNS resolver. I didn't need a DNS resolver that actually resolved DNS. I just needed a DNS resolver that returned exactly what I wanted it to return, right? So I had to go back, create a function to, set the DNS resolver, not create the DNS resolver just in the object constructor, so that it could use whichever one was provided to it. So yeah, I will say that about static languages versus dynamic languages. It's definitely a little easier. When should you be testing? Well, all the time. But development time, build and compile time during QA, and in production. You can do automatic tests on builds. You can just run your test script real quick. You can have a large test suite that's, tens of thousands of tests take a couple minutes. And wouldn't you rather spend a couple minutes doing that than putting a fire out at 2 o'clock in the morning for 4 hours, which I've done before during my bachelor party? So bugs can take hours, especially small ones, because they're kind of hard to find sometimes, and it costs a lot of money. Production testing, what I mean by production testing is monitoring. Okay, if you have a website, it logs people in, you need to have a little monitor that just sits there and logs in every 5 minutes and logs out. Because the fact is, you're going to be the first person to know if your website is having problems. You don't want people going on Twitter saying, oh, this website's saying I can't log in. Maybe you want one person saying, hey, I can't log in, it's cool. You're cool customers. But if it just keeps going and you're the last person to know and you find out at, 3 hours later because it started happening at 5 a.m. and you woke up at 7 or 8, you're done. That's just a really, really bad user experience. You're going to lose users. So this long blurb here. So in the case of an externally available API, if you're building like a B2B kind of thing where you're providing an API, you should make sure to provide a real or mostly realistic test environment for your customers to use, for your users. If you can't set up your own, you can use services like Apiary, and they help you set up mocks. It's apiary.io. I would highly recommend having a real test environment that just has a test database. Your users are going to have much better code, and when they do well, you do well, right? The ecosystem, kind of everybody's a ship that floats on water that goes up, right? Until you get really big and then everybody starts fighting, but that's another story. So testing a netkey. This one is tested with unit tests. As of this writing, we have 1,748 Python unit tests. Our JavaScript is tested with Karma and Mocha, using the Synod for stubs. We have 491 JavaScript unit tests. We have a pretty small code base, right? That's over 2,000 unit tests for a relatively small code base. For example, one of our user API file, 1,200 lines of code. Our test for that is 4,900 lines of code. So it's almost 5 times. And just remember, test code is usually more verbose than the actual code itself. Also, that 5 times is also because we've done some automation. So a lot of our setups and teardowns, stuff that you do before the test and after the test, has been automated, genericized, pulled back up into super classes, that kind of thing, right? So if we didn't do that, that 5,000 lines would probably be closer to 7,000 if it was just written over and over and over and over again. All right. So once again, we test early and often. We test on build. We test on deploy. We have a crazy amount of monitoring. At some point in time, everyone in our company has been in operations. I was in a NOC for a year when I was 23. I responded to alerts. That was my gig. And I truly since then realized the value of monitoring. You need to monitor everything. You need one machine and it just monitors. Okay, because you need to find out about these things before everyone else does.
How would you implement that monitoring?
You can use free tools like Nagios or Xenos. You could have a script that just runs on a cron. You can do that emails you. It would get annoying after a while, but it's better to work on the signal to noise ratio later, right? I have no problem in the first month of something being in production getting an email every 15 or 20 or 30 minutes. Honestly, I don't. But after a month, we've either fixed everything that's wrong, or we tone it down so that you really only get alerted when there's an actual issue. So however you do your monitoring, just do it. It's not really an if you're going to monitor. It's like there are things like New Relic that are really easy to use, that are free, up to 10 servers, and they do system level monitoring too, so you can find out if there's an issue between CPU usage, memory, I/O. If you have some sort of swapping or churn or something, you'll find that out, which is generally really helpful. Xenos does that as well. Nagios has been doing that since like 1990. I mean, it's been doing it forever, right? Also, open source testing. Do you have any more questions about monitoring?
No.
I mean, it's like the super high level overview. Once again, if you have any questions, I'll give you my address, my personal email address if you want to ask a question, because I know everybody's kind of chilling right now. So open source testing, right? Open source testing, it's very important to have all of your open source stuff tested, completely unit tested. We have a bunch of modules out on GitHub, and they need to be tested. Number one, because it proves that your software is doing what it says it does, right? A lot of installers, Ruby Gems, Pip for Python, even NuGet for C# will run tests when they download to make sure that the code is working, right? Also, it gives an integration template to your users. If you have someone that's using your code, you just gave them a bunch of examples about how your code works. They don't need to ask you, they don't need to do anything. They say, oh, okay, well, all right, that's easy. I'll just do it, right? And last, tests are code, right? So you need to approach tests with the same level of care as code, right? There are more of them, they're more verbose. You may hate them, but they will save your butt all the time, I guarantee you. So when if you're writing tests, then you write your code. Or let's say you decided not to do TDD because you just need to do something right now. Make sure you write the test soon, okay? Especially because you're going to be in the same headspace, right? So don't play catch up. That's the other thing I wanted to talk about. So when we started Netkey, what we did is we wrote a bunch of code really fast. We had our beta up in a weekend, a very, very, very beta up in a weekend. And really, most everything was good after 2 weeks for the initial setup. We didn't have any unit tests. Going against my own belief that we need to have lots of unit tests, we didn't do any unit tests because we needed the speed. So we spent, 3-4 weeks writing all the code. The initial code, things have changed since then. But we then spent 2 months, 3 months playing catch up. Because not only were we working on other things, but then we had to go back, read the code, go, oh, what did I mean here? Oh yeah, okay, and then write the code, right? It's horrible practice. I would never recommend it to anybody. Take the time, do the code. In almost everything else I've done unit tests while I'm doing the code. I don't do a whole lot of TDD myself, but that's because I'm a cowboy apparently. But yeah, do it when you're doing it. The context switching will cost you a lot of time if you don't know what's going on. And the fact is, you could even go through code, go, oh, this is what I meant, and write all your tests, and you're still going to miss something because you're not in the frame of writing that code. You don't know exactly what you were thinking. You just know what it looks like you were thinking, right? So with that, this is my actual questions slide. That's my email address, matt.david@me.com. That's my personal email address if you want to ask me any questions. If you're interested in determining what programming language to use, or if you're really into unit testing. I will say though that while unit testing is kind of a droll subject, it's totally necessary. Because if you don't do unit testing, you're going to run into one of those millions of dollars a day, millions of users lost, reputation gone. And unit tests, once you get going, once you do your first few unit tests and you figure out your unit test framework, they just go like this. You can write your go write case, and then you just copy it. Say, okay, well, this one changes here, this one changes here, this one changes here, this one changes here. It's really very straightforward. There's really not a whole lot of logic to it. You set your inputs, you run your stuff, you verify that it worked. It is totally worth it, and you will be lost if you don't do it. It is a little boring, but it's very, very, very necessary. You will thank yourself later for doing it. So with that, does anybody have any questions?
So with our group, we have, our group has at least some experience with unit testing, but like if we want to be doing this, because we split up the work, obviously, multiple people doing multiple different levels of code, if we want to be doing it each while we're writing it, do you have suggestions for resources to get started? I mean, ours is all going to be in JavaScript, but like going from slim to no understanding of unit testing to be able to do something that's useful?
Look up Karma, look up Mocha.
Okay.
They will give you like here's a template. It's actually, that one is more behaviorally driven testing, where you say it does this, and describe this object. It does this. It does this. It does this. That's the test. JavaScript testing is very fast once you get it going. Very fast. Most IDEs like WebStorm or PyCharm or whatever work, and we'll just run unit tests. You just hit go, and it'll run Karma, it'll open up a Chrome browser, it'll run it through everything.
any questions in general, working at a startup, working at a large company? Justin and Don, Justin is the CEO actually, and Matt have been working together for over 10 years now, so you can ask some questions like, what does it look like for working together over 10 years from different companies, right?
Do you have a preference right now for startup atmosphere of 6 people versus a large ISP?
Well, it depends on the 6 people.
And his boss is right in the room, or one of his,
Yeah,
yeah,
true.
no, but seriously.
Deeper on that, like, what makes a difference on different 6 people than this different 6 people? And what are the key characters?
Well, I'm going to relate this to music. I used to write music. I used to throw dance festivals and stuff when I was younger. And everyone wants something. If you're working with people that are like, yeah, it's cool, all right, let's do stuff, and they never do it, they're all talk, those people you don't want at your company, right? If you say, hey, I have this problem, let's talk about it, okay, you have the notes, you're gonna do it, all right. Those are the people you want at your startup. Especially because as a startup you have to move nimbly, you have to pivot. You say, okay, well this isn't working, we're going to go here. Okay, this isn't working, we're going to go here. You need to have a prototype done. These 6 people, 4 of which, well, including me, 3 of which I've known for a long time, 2 of which are new and are cool. But I've been working with Don and Justin for a long time. Justin was actually one of the guys that was working on building the internet in the early 90s, taking it from like kind of an academic pursuit and making it, real. He's a guy that had a wireless mesh network between him and a bunch of his other network engineer friends in high-rises in San Francisco in like 1998, 99?
98.
I mean, and they all had fiber into their houses because that's what happened when you were a network engineer when you were the lead network engineer in that time.
You had fiber drive.
You had fiber in your house. They all had wireless networks between, high rises. And he's a really smart guy and he's really cool. Dawn, same thing. She's been working in networking in the internet space since
Before the internet.
since before the internet.
95.
So they went, just a little background, Justin and Don, they went through 3 companies and brought 3 companies to the IPO stage, and this is the 4th.
I should know about.
In this case, not really. I mean, if you want to work on blockchain as like the blockchain core, you need to know C++. If you want to work on, there's actually a lot of people that want a lot of help with the blockchain, right? There are a lot of developers, but they need more. But realistically, if you're working in the blockchain space, what you're really doing is you're communicating with a blockchain server, whether it's the Bitcoin core server or whether it's something that someone else has written, BTCD, whatever, and you're essentially making RPC calls. What you're really doing, if you're doing some cool stuff, is you're writing really cool transactions, smart contracts, multi-signature contracts. You're using things like HSM, which is a hardware security module, which is essentially a tamper-proof box that generates keys, encrypts, decrypts, signs. And those are really available in all languages. Well, not all languages, but most languages. For the HSMs, you need to communicate generally in what's called PKCS number 11, which is a protocol that's been defined for public key cryptography, and it's a way to communicate back and forth. There are some other ones, but that's the base standard. But honestly, you can write it in Python, you can write it in Java. What's really important in the blockchain space is really understanding what's going on. Right? Understanding how transactions work, understanding how the blockchain works, understanding if you go into the actual Bitcoin core development, like what's the unspent transaction set? What is it? Why does it matter? Why are there transaction size limits? Why are there giant transactions? Why are there these really complex transactions? How do smart contracts work? And there's a cool language that Bitcoin uses called script. And what it is, it's a stack-based language, right? So you push data on, and then you push on and you say equals, right? So you have data equals. It's like reverse Polish notation if you've done any of that fun stuff. We're basically like a reverse Polish notation calculator. You would put in, like, you'd put 10, 2, hit divide, and you would get 5, right? Because it essentially pushes data onto the stack and then does operations on that stack. And it's really powerful. There's a limited number of instructions that it can do, but some of the instructions are things like, verify a signature, make sure hash codes are the same, doing hashing operations, all that kind of stuff. And it's really interesting. It's really interesting. Actually, the first time when I actually had to sit down and really look at it, I sat there on a spreadsheet and I literally had a stack like this because it was the first time I looked at it. I said, okay, well, here's a transaction. And I literally had every column was a new version of the stack, right? And it's really cool. I mean, I love that stuff. I could do that stuff all day. It's really fun. That's really where the nerd comes out. Making a web page is fun, but making a web page that really does something, that interacts with APIs, that, we're writing a program that interacts with things like the blockchain, or, does geolocation stuff, writing an iOS app that does it. I mean, that stuff's really fun, right? Where you're doing math, you're doing logic, and you're designing this system. That's really, really a lot of fun. I am also the NetKey graphic designer, in case anybody wanted to know. So we are multifaceted here.
See, that makes it extra valuable, combining the design and development side of it, right? A lot of people say that it doesn't speak. Those two type of people doesn't speak the same type of languages, but some unicorns or like super great people can master the two actually became ultra valuable. Any other questions? And another comment that I heard about Bitcoin or blockchain is you either get it or don't get it, right? So try to be on the get it side. You can work on it.
You could not get it for a little bit. I mean, there's a bit of a learning curve. It's totally okay to not get it for a little bit. Read up on it. It is really interesting. I had a good point, but I don't anymore.
All right. So I guess thank you very much.
Thank you for having me.